So let us solve all these questions on mass defect and binding energy. Question number 1. When a uranium-235 needs to undergo fission, 0.01% of its original mass is changed into the energy. How much of energy released if 1 kg of uranium undergo what? Fission. So the percentage of the fission is 0. What? 0 what? 1. Solution. So we are given a 0. What? 01. By converting to what? 0.01, yes, of its original mass changed to this. So that will be 0.01 in mass. It will be, the energy will be, this in percent is 0.01 over what? 100 multiplied by what? Of original mass. 1 k what? 1 kg. The value given here, assume you are given 0.2. It is 0.2 divided by 100 multiplied by the original what? Mass. If this place is what? 0.05, then the original mass is what? Is 2. It will be 0.05 over 100 multiplied by what? 2. That's what I did here. That will be the what? The mass. Or let me do it in this way. We know that what? Using binding energy equal to the what? Change in mass defect c square. And the mass defect is what? Change in E. What will be the what? The mass defect. It is 0.01 over what? 100 multiplied by original mass, which is what? 1. That will be the what? The mass defect energy. So our C here is constant, which is what? 3 times 10 raised to the power what? 8 square. They will not give you the what? The value for C. C is what? Is constant. You know that what? The speed of light is 3 times 10 raised to the power 8 meters per second. Square it by pressing your calculator. Pressing your what? Your calculator, we are supposed to arrive to 9. Where the calculator what? 9. That will be changing. Binding energy will be what? 9 times 10 raised to the power 13 joule. Where is the calculator? This will give you net square. This. That's the binding energy for question number 1. For the question number 2, we are given that what? 1 kg of hydrogen is converted to the what? In 0.993 gram of helium in thermonuclear reaction. The energy released is, the energy released there is also what? The binding what? The binding energy. So what you first of all calculate the what? The mass. Change in what? The change in mass. The mass defect. Question number 2. Say the what? Using this change in E equal to the what? Change in MC square. What is change in M? Change in mass. The mass given here is what? From 1 converted to the what? 0.93. That will be 1 minus 0.993 to give us what? 0.00 7 gram. Mhm. Change in what? Change in mass. 7 what? 7 change in what? Change in mass. Then the next thing that we apply to is in gram. Yes. You now use what? Change in energy. The burning energy will be what? The mass given here 0.007. This must be in kilogram times 10 raised to the power what? 3. Mhm. Then what is the speed? C here is what? 3 times 10 raised to the power 8 everything square. So 3 raised to the power 8 everything square, it will give us what? 9 multiplied by 0.0073 this. So if the change in energy will be what? 63 times 10 raised to the power 10 joule. That will be the final answer for what? For the, you can observe that question number 1 and 2, we use what? Estim energy what? Equal what? Equation. And then if you look at the 2, the mass is not given directly. So this one, we are given that what? Form of what? Or percentage. This one, we are given the original mass, convert to this. You have to find the what? Energy release. Subtract this from what? From this, convert to what? To the kilogram. That's what I did there. Multiply by what? By speed of what? Of light. So let us move to the what? To the third one, which is question what? Number 3. The mass of neutron and the proton are this. If you look at this now, mass of what? Of proton is 1.0073 atomic mass units. Mass of neutron is 1.0087 atomic mass units. Good. This is this one for neutron, this one for proton, respectively. If the neutron and proton are combined to form a helium, this alpha of the mass. So the mass of alpha given, this is the capital letter M. Atomic mass of what? Of helium given is what? Is 4.0015 atomic mass unit. The binding energy of helium of the nucleus will be, and we are given that what? 1 atomic mass unit equal to what? 3931 mass electron volts. Good. This is what we are given, and we are asked to find the what? The binding energy. So if you could still remember, there is a formula which say that what? E equal to the what? Number of proton times mass of what? Proton plus number of neutron, mass of neutron, minus m, everything bracket what? Atomic mass what? MEV. So I give you this formula and the binding what? Energy. So this is what we use. And the element given here is what? Is helium. We're talking of helium here. And if you look at what? Helium is atomic number what? Look at helium is atom helium 42. So here now, you can now say what? The change in energy E, here it will be, what is the mass of proton? 2 minus 4. So the proton is 2. You have to multiply by the mass of proton given 1.0073 plus mass of neutron 2 minus 4, 2. We have 2, this n is 2, multiplied by what? This mn 1.0087. So we'll unify what? Atomic what? Mass. which is what? 931 MeV. No, this is a mistake. Yeah, this is a solid mistake. Mhm. Minus M. What is this M? 4.0015. This M is what is this? Everything you add is this, subtract it. You now multiply by what? MEV. So by pressing your what? Your calculator. So from this now, by pressing this, you have change in should be 2.84. If you add this together minus this, the final answer will be what? 2.8 what? 4 MeV. That will be the what? The binding what? Energy. Yes, don't forget that what? One univar one atomic mass unit is 931 MeV. So here now, this place is with in what? In U. So and we are know that what? This 1 AMU, go to the what? 931 of this. You now multiply it by 931 MeV. That's give us what? This. So for the fourth question, we are given what? The mass of chlorine 35 is this. Calculate its binding energy and what is the binding energy per what? Per nucleon. So this is very what? Easy. For the fourth one, fourth question. The same thing. Okay, let us do it now. The binding energy okay. On the fourth question, the binding energy E equals to what? Equal to Z number of proton, mass of proton plus N mass of neutron. Everything we have there minus M into what? MEV or uni what? Mass this. So we are given chlorine. The M for chlorine is this. This is M, mass of proton, mass of neutron, number of proton and neutron. It should be what? The binding energy, it should be band change in E. Equal to what? What is binding energy? Number of proton, the 17 multiplied by what is the mass of proton? Same thing with this one. And we are given it here. Mass of proton is what? 1. Mass of proton, yes, is 1.0073 The one given here, 7822. 7822. This plus mass of what? The number of neutron times the mass of what? Of neutron. So 7, if you subtract 17 from 35, we are left with 18. It will be 18 multiplied by what? Let me code this. Plus, that will be 1 point. Neutron is 1.8892. 0.0892 ATM minus 3.4, 34.9800. So, and this AMU is equal to the what? 931. So, multiply by what? 931 MeV. So, that should be the what? The binding what? Binding energy. So, calculate the what? The binding energy. And what is the binding energy per what? Per no what? Per nucleus. So, here if we have what? The binding energy will later give us what? 8.22 eV. That's the binding energy. But to know the binding energy per nucleus, the binding energy per nucleus will be what? The energy per what? Nucleus is binding energy over what? Nucleus. So, what is the binding energy we have here? Binding energy per nucleus. The binding energy is 8.22. What is the what? The number of what? Of nucleus. Total number of proton and neutron, which is 35. No, I said nucleus is what? Is proton plus what? Neutron. Proton here is 18, 17, which is what? 35. Or approximately this one, 35. So to now be what? Over what? 30 what? 35. So help me to press the calculator. What will be the what? The final answer. Was what? 0.2389 MeV. That is the burning energy per what? Per nucleus. So let us look at what? The question number 5. The burning energy per nucleus of oxygen is this, and that of what? Oxygen 16 is this, and that of what? Oxygen 17 is this, 7.5. The energy in MeV required to remove a neutron from 17 is from 17 is to solve the 5th questions. It required question number what? Number 5. This is the equation of the reaction. 17.8. The binding energy of nucleus and this. The energy required to remove neutron from, it tells us that what? This 16 come from what? From 17. So we have it at the reactant side. At the product side, we have 8, 16 plus what? Neutron. If we add this one plus this, give me this. So you are now add that what is what? The binding energy per nucleon of this and the energy required to remove a neutron is this. So the energy required to remove a neutron is what? Is E. That's what we are asked what? To find. Now say what? The energy required, let me call it what? What? Energy what? Required. Can I say what? The energy required to be equal to what? The binding energy of oxygen 17 minus binding energy of oxygen 16. So the energy required, what is the binding energy of energy 17? Is this? Mm, mm, yes, energy what? 17. Before 17, we are given this. So the number of the mass number here is what? Is 17. 17 multiplied by the binding what? Energy we have here, which is what? 7.75 MeV minus the binding energy of 16. 16 multiplied by binding energy of 16 is 7.97 ME what? V. So the energy in what? In M what? MeV. So if you now multiply it, then by subtraction, the energy what? Required should be equal to what? 4.23 MeV. So that is what? The energy what? Required to release a neutron from oxygen what? 17. Look at question 6. We are asked to find the water to calculate the total binding energy. The total binding energy and the binding energy per nucleon of boron 511, given that the mass of this is this. But it's the same method with what? With this one. This question number 6. What we need here, let me just help you to analyze it out. You help me to solve it and give me the what? The answer on the comment what section. For number 6 question, we are given what? Beryllium. So the first of all, find the number of what? Of proton, which is what? The number of proton here is the number of proton, we call it what? Z, which is 5. The mass of proton is the same thing with what? With this one, 1.0073 in AMU. So number of neutron, 5 minus 11 is 6. So the mass number of what? Of neutron is 1.0087. Once you know this, and your real mass is 11 point what? 00 this. So to know the binding energy here now, you will add binding energy if you equal to what? Z mass of proton plus what? N mass of neutron minus M. So you will multiply everything by what? AMU. So by doing this, you have what? This. What is Z? Z is what? Is 5 multiplied by what? 1.0073 good plus what? 6 into what? 1.0087 good minus the what? 11.009305. So note that what? 1 AMU is equal to what? 931 MeV. The final answer you get here, it will be your what? Your binding energy. So for the last one, which is 7, let me solve the question number 7 here. Calculate the packing fraction. You know that what? Our packing fraction is what? In the formation of what? Of argon atom, 40 this, and given that what? The mass number of argon should be D. It's very easy. I said what? Isotopic what? Mass minus, what do you call it what? Real what? Or nuclear mass, or minus real what? Mass over new what? Nucleon. So the fraction multiplied by 10 raised to the power what? 4. So nuclear fraction, what is isotopic mass here? Is what we have 40. We have 40 minus what? 3.9962384 over what? Nucleon. What is the nucleon stand for? Nucleon is what? Is the total number of proton and what? And neutron, which is also what? This one is 18. 18 minus 40 equals 22. That will be 40. Multiply by what? 10 raised to the power what? 4. That will be the what? The final answer. So it's like we are done with what? The calculation aspect of binding energy and mass defects. That is all about the nuclear chemistry.